So, hello and welcome. My name is Misha, and I'm here with Shimon, Marek, and Anna. And together, these past days, we worked on a project from GasNet company, more precisely how to renovate or get a new approach to gas pressure stations in a natural gas distribution network. And without further ado, I will give my word to Marek, who will tell us more about the problem.
So hello. The main problem that we will be solving or was solving is the gas pressure reduction stations. What is it and why do we need them? In the pipelining, in the gas pipelining that where flows the natural gas that we use in our stoves or our heaters, the pressure in there because of the distribution has to be really high, about 22 bars. In our homes to use it regularly, we need it to decrease it to 1 bar. This has a lot of problems because we have to obey physical laws, and the nature of this process is adiabatic. So with the drop of pressure, it also drops in temperature, and it actually drops a lot. Because of this drop, the pipeline can be frozen. The hydrates of natural gas are formatted there, and it blocks the flow of the gas itself. That leads us to the solution, which is preheating. Current solution uses gas pressure reduction stations that are actually burning the gas itself. At the first glance, this comes with a lot of negatives. The first one is you are burning the gas that you are trying to distribute. So you are burning your own resource you are trying to sell. Next one is that actually burning a lot of natural gas this way produces a lot of greenhouse emissions. That is really bad and really costly for the company itself. And next thing, we basically waste the potential of the energy of the pressure drop. So we came up with a solution that will be presented by Shimon.
So we knew only that we can work with the pressure drop. That meant like reducing the pressure from 22 bars to 1 bar. The obvious idea and obvious solution for us was to implement expansion turbines in a system and to try to get some electricity from the turbines. But because of the expansion in the turbines, we are still dealing with the same problems: the hydrate formation, fouling, and also freezing of the pipeline. So that's why we need to also preheat the gas before the turbines. So our solution is working with two-stage expansion in the turbines, and the preheating is done before every stage of the turbine. The preheating is done with a combination of geothermal energy and also a heat pump that ensures that the gas before the expansion will have a proper temperature, and we can or the problems are not happening inside the turbine. Generating the electricity from the turbines gives us enough power to run the circulating pump in the circle, and also to run the heat pump, and also the excess of the electric power can be sold to the grid as a well, we can talk about green electricity because we are burning, nothing is burned, and everything is zero emission. Yes. And thanks to the variety of, or the wide range of turbines and heat pumps, the solution can be practically used for every demand, so in every pressure reduction station.
So Our main expenses involved in implementing our project is the cost of acquiring and installing the turbines, heat exchangers, heat pumps, but there are also additional expenses that are for ground drilling and piping. And as you can see in the graph, the most of the expenses are for the turbines. But yeah, while these figures may seem significant at first, they're outweighed by the long-term benefits as no gas consumption, no emissions, and also green electricity production, as Shimon said. And to determine the feasibility of our proposed solution, we conducted an analysis, and the payback period would be around 6 years.
So we present our resources also, and that is all from us. Thank you for your attention, and we give space to your questions.
Well done and excellently in time. So, are there questions from the jury members? I would invite, of course, from GasNet, if there are questions, remarks.
I have no question, but I would like to say electricity, which is produced by turbine, is not as green as you may think. We still don't know how green it is because we need to solve it with government. They told us it may be not so green. So just for information.
Then you have to change the color a little bit in the next presentation. Are there any other questions? Yes, please.
You mean the price of the turbine we were calculating with, or? Well, the price of the device, all the devices, we made the research and we found the approximate equations, how to calculate, for example, the cost of the turbine, cost of the heat exchanger. And the benefits for us are, of course, the less or no consumption of the natural gas. And for that, we took like the market price. Yeah, I mean, in like this era, in this time, it is pretty hard to determine the price of the natural gas, but we took some like lately prices to define the payback period.
Thank you. Any other questions? Yes, please.
Maybe I missed it, but I don't have the context. The pressure reduction stations, like what is the scale of the stations? Like, do we need a station for like block of buildings, or do we need it for each house, or how many stations are in Prague?
For example, in Czech Republic, there is over 3,000 reduction stations, and the variety of the sizes is pretty huge. So therefore, we propose this solution. You can adjust the size of the turbine, size of the heat pump to the specific solution, to the specific demand.
Okay. Of course, your fellow students can also ask questions. Usually they don't. Maybe one more question, yes?
So maybe I will ask one more. Like, so what is the most innovative, like in your idea? I suppose that most of the things are somehow already known, but why no one did it before?
I mean, that's probably not the question for us, because yeah, I don't know. Probably the cost of the devices, for example, the turbines are pretty expensive, and also maybe the solution isn't that easy to implement. It can be considered as a complicated, you know, to have a ground heat exchanger with a heat pump all together working in an efficient way. So maybe that's why.
And also, as far as I'm concerned, I think there might be some legal problems at some places with the drilling and placing the heat exchanger under the ground, but you cannot drill everywhere. So that might be a problem.
Okay. If there are no more questions, then a big round of applause.